discussed.
Yes. Here we start.
Just recapitulate. Live questioning.
Yes.
Welcome to the third live session of the MOOC course Solar Energy Engineering and Technology. So before we take the question answers, let us recapitulate what we have covered in module 9, module 10, 11 and 12. Yeah. So in module 10, we were primarily discussing about solar concentrating collectors. In module 11, we were discussing thermal energy storage. In module 12, we were discussing about emerging solar energy technologies. In module 10, lecture 1, we have discussed about fundamentals of concentrating collectors and its classification based on reflecting type utilizing mirrors, refracting type utilizing Fresnel lenses, imaging type like point focus and line focus, concentration ratios, again operating temperatures, tracking, basic energy equations, and also we have analyzed parabolic trough collector and heat transfer. As you can see, we can develop the equation for useful heat gain, which is nothing but QU is equal to AA multiplied by S minus UL by C in bracket TPM minus TA. Okay, and also we have developed the expression for concentration ratio. Okay, so if we consider this kind of configurations, so this will be W. Okay, and this is the diameter of the tube. Okay, which is represented by D0. So that's how this C is effective aperture area to the absorber tube area. So this W minus D0 multiplied by L, because this is the length of the collector and concentrator, and this pi dl is the area. Then if we simplify it, then what we will get, this is something like W minus D0 by pi multiplied by D0. And in module 10 lecture 2, we are discussing about working principle of different concentrating collectors and its comparison. Like power towers and troughs are best suited for large scale like grid connected power projects in the range of 30 to 200 megawatt. These or engine systems are modular and can be used in single dish applications or grouped in dish farms to create large multi-megawatt projects. Parabolic trough plants are the most mature solar power technologies available today, and power towers with low cost and efficient thermal energy storage promise to offer dispensable high capacity ratio or capacity factor solar only power plants in the near future. In module 11 lecture 1, primarily we have covered thermal energy storage, which includes sensible heat storage, latent heat storage, and thermochemical storage systems. In module 11 lecture 2, we are discussing about fundamentals and working principle of salt gradient solar pond and its temperature profiles and energy balance, operational shortcomings, then types of solar ponds its applications, and stability criteria. As we know, this d rho is the density, d rho by dx has to be greater than 0, right? So what I mean to say, so if we take a section here and if it goes down is represented by x and rho represents the density, so this density gradient has to be greater than 0, right? So as we know, this density is a function of concentration and temperature. So by analyzing what we can conclude the stability criteria something like this, which is nothing but gradient of concentration has to be greater than of this mathematical expression. Okay, so from that we can calculate what is stability criteria. So this minimum concentration gradient required for maintaining a given concentration gradient at a particular level in a solar pond can be calculated. Okay. So in module 12, lecture 1, we have primarily covered emerging solar energy technologies, which includes perovskite solar cells, organic solar cells, dye-sensitized solar cells, then quantum dots. And also we have discussed about photovoltaic thermal technology and solar fuels technology. In module 12, lecture 2, we have discussed primarily about solar energy applications in solar distillation, solar cookers, solar refrigerations and air conditioning like vapor absorption system. So both aqua ammonia refrigeration plant and lithium bromide refrigeration plants were discussed, and solar space heating and cooling, and solar thermal devices for low, medium and high temperature applications were discussed. So these were the components we have covered from module 10 to 12. So thank you very much for your attention about this. So we have just summarized what we have discussed. Now we will discuss some of the questions raised by the students. So one of the students is asking, please kindly upload assignment solutions. Of course, this will be uploaded soon. Most of the things are already been done. Then I will discuss some of the questions raised by students in the discussion forum. Maybe you can move to presentation. Yeah, in one of the questions or queries, it was something like it appears from the graph that the annual collection efficiency is 100% for depth near 140 centimeter. Is it true? Earlier we were told that efficiency of the collector ponds are less. Yeah, thank you very much for your concern and your comment. So I will explain how to read the graph. See here, in this graph, as you can see, in the vertical axis what it shows is the annual collection efficiency, and in the secondary axis what you can see is the mean extraction temperature, and in the horizontal axis what you can see is the pond depth. Okay, so this curve is for collection efficiency, as you can see here. So maximum collection efficiency is observed to be around 60%, okay, at a depth of about 25, okay, or 20 meter, right? So to 20 centimeter, right? So at this 20 centimeter we will get the maximum collection efficiency of about 60%. So please read this plot, not this plot, okay? So this plot or this line is for mean extraction temperature. So mean extraction temperature can be achieved 100 degree C at a depth of 140 centimeter. Okay, I hope that your queries are now clear or doubts are clear. Okay, so next question, what is happening in this video? So this student is asking about shadow analysis. Okay, so actually in this video that shadow analysis is not shown, but since you have asked this question, so I must reply to this question. So what I will show here, see, so if this is a solar collector, okay, and it is installed at certain angle, so this is the height, right? So normally if you know this height, then from that you can calculate the distance between these two collector, so which is something like 3 times this height. Okay, and again we can mathematically express something like this. Okay, so if you are interested to do very precise calculation, you please follow this calculation. Otherwise straight away you can follow this thumb rule, right? This distance between these two collectors should be 3 times the height of this collector. Okay, so hope you are okay with this reply. And now this question is, how is the possibility of solar based charge station for e-vehicle in future? It's a very good question. So I must appreciate this question. See, now electric vehicle is coming in a big way. So all people are trying hard to get the energy independently to charge what is called electric vehicles. Of course, solar energy will be playing a big role in providing power to the electric vehicles, because independently this kind of plants can be installed and power can be provided to the batteries which is used in the electric vehicles. Yeah, so it's a big issues now. As you know, in next coming 2-3 years, there will be full of electric vehicles in our cities and villages. Okay, so it's a very good question. Yeah, so here this question is something like, can you please elaborate on that? Other courses have given their specific exam instructions. Will there be numerical problems? Yes, of course there will be numerical problems. And will the measure equations for the problems will be given? Of course, we'll give the no measure equations and very long expressions and correlations. But of course, you need to know remember some of the conceptual equations. So, for example, say if we ask a problem something like say extraterrestrial solar flux, okay? Say this represents something like ISC days, which is nothing but ISC multiplied by 1 plus 0.033, we have cos of 360 by 365 n. Okay, so n is the nth day of the year. So if we ask to calculate this extraterrestrial flux which is falling on a particular day, that you must able to know develop this kind of expression, and you must able to calculate this ISC days, right? So this variable is only n is the nth day of the year. Okay, so again, say for example, you are you need to calculate declination, so delta. Okay, so which will be in degree. Okay, so what is the expression for declination? It is 23.45. Okay, then sine of 360 by 365 284 plus n. Okay, again n is the nth day of the year. So that kind of expression I will not give, because this is very fundamental in nature, and many a times we have used this expression for solving large mathematical or numerical exercise. Okay, so I hope you got it, the kind of things to be remembered, and then what kind of equations to be given in the exam. So of course I am helping you all so that you don't face any difficulty in solving the numerical problems. Okay, so if I have to ask say something like a very long expression, say for example h naught bar you need to calculate, so you need to have a very long expression. Under the conditions, of course I will provide the entire mathematical expression. Okay, so don't worry about that. And yes, I can see for final exam very hard to remember all the numerical formulas. Don't worry about those things. We'll no will not give such a hard questions. Okay. How many questions will come in the exam, and how many of them will be numerical? Oh, it's difficult to say because it's a quite proportionately we have made the question papers. So I think this is not a matter of question. Just you prepare well and study the lecture notes properly, then you can able to solve all the problems. I hope you have done the assignment very sincerely, so then there is no issues of no worrying about question papers in the final exam. And how to optimize the thermal absorber parameters like mass flow and diameter to construct PVD system. So see, these are the design parameters. So you need to have a no practical setup to optimize those parameters. Okay, so we are involved in designing PVTs where we have no design different kind of configurations, and still that requires a lot of understanding to get the exact idea. Okay, so but what I understand that requires a lot of numerical as well as experimental studies and observations to optimize those. Okay, still this part is in the research, yeah, under research. And yeah, maybe I'll move to here, and someone has asked some questions. Then how possibly solar power based is EV? I have answered this. Solar rooftops, yes, solar rooftop is a very interesting topic. Already, in IIT Guwahati also we have installed about 1 megawatt solar power plant, and which is on rooftops. So this is working fine. So now we use, as you know, every household could be a, or can be a what is called energy generator. Okay, since government is promoting this solar technology, and this net metering system is already in the progress and in the place. So if you install net metering system, from that you can figure it out the amount of energy you consumed and the amount of energy you have generated and given to the grid. So finally the resultant energy has to be paid or has to be gain. This is something like that. And please explain the details about the shadow analysis. Already I have done it. I think you have followed it. How to check the exam center. So I think this part, exam checking, you will get an email from NPTEL office. So you don't have any issues. So the center is quite efficient enough. Everyone will get access. So don't worry about it. And how will the exam pattern? Of course, theoretical and numerical problems will be there in the exam. Do you need to memorize the questions? Already I have given the reply. So sometimes these conceptual things you need to think and write. There is no question of memorizing the things. but these correlations I'll provide so that you don't have any no you don't have to remember those long expressions for solving the numerical problems. It is possible to release solutions of our assignments. Of course, we are doing it, and you will get the solutions soon in the portal. So these were the questions read by the students, and yeah, one guy is asking for exam. Yeah. You must know what is Stephen Boltzmann law and all. So these things we think that these are very prerequisite. You must know those equations. Otherwise, you don't have to know remember the very long expression. Yes, suggest any software to optimizing thermal absorber. Thermal absorber. Software, how software will optimize thermal absorber? So here, see, we need to develop some kind of coding. Like you need to develop, no, coding in C++ or maybe MATLAB. So that way we can solve. But I don't have much idea about any software which can optimize the thermal absorber. Okay. So what I suggest, if you have fundamental understanding about all the components which influences the performance of a collector, then I think you can develop the system. But there are many softwares, but that kind of feelings you will not get. Like we'll have software like I don't recall it now. Polishan, yeah, Polishan is one software. So in that software you can do the analysis, but you don't. Uh, it will be difficult for to optimize the thermal absorber, but you can get the no, rough feelings about how to optimize the thermal absorber. Okay. Yes, these are numerical questions are similar to the assignments. Yes, these are similar to the assignments. So other softwares might also available in the market, so you can have a look. But Polysian is a good software. You can think of it, and maybe you can use it. Good evening, Chittaranjan. Yes, Narasimha, your assignment solution will be provided soon. Is there a negative marking in exam? I don't know. Please read the instruction when you appear for the exam. So this will be written at the front page. No worry, all the questions will be multiple choice. If you have done the assignments sincerely, I don't think you will have any issues in solving the problems in exam. Yes, Karan, you are always welcome. You can ask any questions at any time. Yes, Nitin Choni, you are very correct. We need to consider the share analysis. I will tell one story here at IIT Guwahati when people were installing this solar power plant. Without calculating the shadow provided by the building, okay, near there was a building. So they didn't consider the shadow length. So then when we have inspected, then it is found that shadow is occurring significantly. So then they had to remove all those solar panels from the install site, and then they have to install in other places. Yes, of course, you need to think about it. This is very, very important. Please share your email ID. My email ID is always no, is available in the website, but I can write it. Yeah, exam will be in two sessions, morning and evening, but you have to appear for one session. So, Mr. Sony, you will get no information from NPTEL IIT Madras. I think you will get email when is your exam and which session. Everything will get. Orjut is asking, sir, is it possible to store double amount of energy in a same size cell? What is this question? I am not getting. If you are making such a nice cell, then of course you can make a startup and you will be very rich man. Mr. Karan Sohan. So of course you can take other courses, but the kind of informations which is included in this course is really phenomenal. So if you have done all the assignments very sincerely and you have followed all the videos systematically, I think this will give lot of understanding, which is almost comprehensive. Okay, and there is no bindings that you have done one course and you are not allowed to do another course. Of course, you can do it if you find something good courses. You can always take it, and that will enhance your knowledge. Conception is same whether you are in India or in US or in UK. Conception is same, but climatic, based on the climatic condition, you have to decide what kind of energy technologies need to be adopted. Okay. PPT. So I can see my email address. Anytime you can drop email if you have any technical difficulties. Is there any further scope to study regarding Fresnel lens? If yes, what? Yes, you can study Fresnel lens, because see here in this course a total of 30 hours lectures need to be given. So that way we have designed the course. Of course, no, we can go deeper in sense and you can study more if you want to learn. Say for example, if you want to make a small power plant, then of course you need more understanding how to install, what capacity you need, how to cabling this, how to harvest the energy. Yeah, for individual components you need to have more no knowledge in order to build a power plant. Okay, what I gave, just overall information about the plant and how it operates. Okay, so if you are talking about individual power plant design, of course you need to give more attention about the individual components and its design aspects. When will open this course again? One of my research scholar uh, friends will enroll this course. Yeah, yeah, I think this information you will know when you visit this NPTEL website, and hopefully it will be open soon. So Nitin Soni wrote solar plant art net design elaboration required. If you have notes and any data, please share on email ID. You please write an email to me. I'll see and then I will reply. What is each art made? I don't get what you are saying. So, Mr. Soni, I think you should refer some electrical engineering book for this. So, this is not an electrical engineering course. So, in this course, I tried to provide all the solar energy technologies. Okay. So, if you want to learn more on this HT line and all, then please refer some electrical engineering book. And you can email also, email to me. I'll see how I can help you. I think most of the queries raised by the students in the discussion portal has been replied. So if no questions are there, then we are closing this session today. So thank you very much for attending this course and this live session 3. So all the best for your final exam.